Hello and welcome. This is Legion from Circular Business Association. Today, I'm very happy to be sharing with you all this framework which we have just drafted out so that we can better help people understand the ecosystem sort of standpoint when we're talking about a circular economy for electricals and electronic items. So let's dive into it right now. E&E sector is a very sort of diverse sector in its own right because there are sort of household-based appliances, there are industrial-based appliances, even medical appliances, etc. And therefore, it might not fit exactly as is. But I really wanted to share this framework to highlight that the when we're dealing with this issue of e-waste, you actually have to consider there's so many other players further upstream that actually are involved in that E&E ecosystem before it even reaches that endpoint where you need to do recycling. So let's first run through this framework of that ecosystem, and it really starts off here at this input material part of it, where you're looking at what actually goes into those electrical and electronic items. And that very much depends on what the product designers actually design this product to be, how it delivers the performance, what sort of materials, raw materials need to be put in, at what volumes, etc. How do they actually come together in components? How many components are there? Are they designed to come apart, etc.? So this is really the input material part of it, and it's very much influenced by product designers. And in this space, you're starting to see like digital product passports playing a bigger role, whereby they want to actually almost document the recipe of this product so that not so much for the purpose of like your intellectual property related things, but to know actually where there are different raw materials and components that could actually then be extracted back out for use, right? But as we mentioned, as you document these type of recipes and also document how these products are flowing through, there will of course be issues relating to intellectual property rights, and therefore intellectual property laws is another aspect, and all the players involved in that, from lawyers, from the people registering patents and things like that, also are involved in that process. Another item that also is getting more and more involved in that input material phase of it is the life cycle assessment, or the product carbon footprint sort of realm of consultants, of measurement companies, of those who are testing all these different products, because we really want to be documenting how much of those carbon is embedded inside the product early on, so that you would be able to have a fairer understanding in terms of whether or not there were carbon savings further down the chain, right? So this is something that is sort of like right at the beginning, what actually goes into those E&E products. Now, from there, of course, we go into more industrial design and into the manufacturing part of these E&E products, so that they can reach the market at much bigger volumes. And then you would have the distributors actually come into play, because they would be necessary in order for those products to reach the market. So from those distributors, you sort of reach the first batch of users. And the first batch of users, at this point, most of the time, E&E products, especially I think the ones that are sold off, don't really receive that much sort of after sales care. But there are, of course, some E&E products that have a lot of after sales care. And this is a realm where it is growing in terms of, lengthening the life cycle of the existing products, so that can stay functional for longer. This touches into the range of, maintenance, repair, and maybe even refurbishment and then remanufacturing. So in order for this after sales care part of it to become sort of economically valuable, there is of course the issues of whether that product design is able to be repairable. Is it modular enough to be taken apart and then replaced with other things? Is it remanufacturable? And we're not just talking about taking out raw materials like gold or silver or copper or plastic or glass. We're actually also talking about the modular modularity of parts, of components, and then into the input materials. And all of this is necessary in order for these activities of maintenance, repair, even refurbishment and remanufacturing to actually happen smoothly. Now, what are the technologies that sort of influencing into that space? There is that issue, of course, of returns and reverse logistics, because if there were any reasons that they needed to bring in the product again for repair, or they needed to send over, these parts and things to deliver the after sales care, then you would need a logistics players that can handle that reverse and returns logistics. Number one, to assess what's actually wrong with those products, whether it's a part issue, a component issue, or is it actually a material that needs to be replaced completely, or there's just people who need to do that triage of assessing and then directing them to the right aftercare, after sales care services. Apart from that, there are also those players that's getting involved in terms of making products as a service model. So business models whereby it no longer is the distributor just selling it off to the users. These distributors are actually retaining the asset, and just sort of like lending it to these users to use, and these users actually pay them as per use, right? So we've seen examples of this in the circular economy, where people have paid for, let's say, the use of washing machines, or maybe even for laptops and desktops. They don't own those laptops and desktops. They're actually paying for this as a service. Apart from that, another technology that is going to become even more important and is already starting to see players entering that space is the Internet of Things related technology, apart from the digital product passports, because these two are actually really important to actually track and trace the assets as they are performing. So while they're with the first batch of users, you want to actually know what's the health of those products, whether or not they would be in need for replacement, or maybe they have certain parts that are starting to fail, they're using a lot more energy than expected. And that is what actually enables this product as a service model, or even the predictive maintenance type of models to come into play, so that you can deliver much better after sales care, apart from just selling off the product and then losing your business value from that asset. Now, apart from that, though, we actually have to look and consider, where these parts, components, and input materials actually come from in order to do all these activities in the maintenance, repair, refurbishment, and remanufacturing parts of it. So, apart from the digital product passports, there's of course players in the resource recovery, and at this point, I think it's very easy to call them recyclers. But from the way that recyclers are treated today, is very much at just the sort of like input material level, like plastic or copper, bronze, etc. But when we're talking about resource recovery players, we're actually including another whole suite of other players. They're doing more than simple crushing or simple sort of melting down, etc. What these resource recovery players actually need to do is to have sufficient technical, skills to identify the parts and components that still are functional, and then to extract them with such precision so that they do not spoil those parts and components, so that can then be accumulated and then brought back into the economy to service this maintenance, repair, refurbish, or remanufacturing sectors. But of course, just having that alone is not going to be sufficient. You will also need players involved in the quality assurance part of it to make sure that those parts and components are actually at a certain level of quality that can deliver a certain degree of performance, so that there is more confidence for the buyers in the market to actually purchase them for further use. So you can imagine that in order for this section here to actually be functioning well, not only will you need those really high-skilled resource recovery players, you need the quality assurance players, you also will need aggregators and distributors, because these are probably in sort of like much smaller in volume compared to, let's say, buying a input material from the beginning, right? So these aggregators aggregators and distributors are quite different from aggregators and distributors of, the endpoint recyclers. They're also quite different from the aggregators and distributors before the first round of manufacturing is actually done. So on that note, we've actually received a lot of feedback from our community about the restrictions that goes around the transportation of these parts and components across boundaries, right? So across nations. So therefore, you have players actually involved in the import and exports, as well as the customs regulations and trade agreements that actually need to come into the picture because of that degree of volume that's available. It's very unlikely for a single domestic market to be able to get sufficient aggregation of those resources. Yeah, so you might not have, let's say, enough capacitors that are recovered from your domestic market. Or let's say if you're talking about electrical and electronics from your electrical vehicles, there may just not be that many electrical vehicles in your own country to allow you to actually get back those assets to do maintenance, repair, refurbishment, or remanufacturing, right? So at the very least, it seems like a regional sort of approach towards these recovery of these assets would be necessary, and therefore these import-export as well as custom regulations, import duties, trade arrangements, bilateral agreements, multilateral agreements, actually they are really important in allowing business players to actually come in and play these roles sufficiently so that this part of the economy can actually thrive. Now, of course, there are some technology developments that's happening in that space. For example, 3D printing had been coined as an option for the printing of parts components in order to match what was actually needed for the maintenance, repair, refurbishment, and remanufacturing. This sort of like draws together with the just-in-time type of production, but what it really requires though is sort of a pure form components and parts, single material, so that you would make it more economical and efficient to sort of 3D print them and then get it when it's recovered or broken, you can actually put it back into that 3D printer. Now, unfortunately, a lot of the products that we have today are not single material, and they are comprised of different components or parts that may not actually be that easily separated. So although this 3D printing technology is something definitely there are businesses looking into that. It's not yet like super mainstream. One really good example of that is actually from a company called Signify. They used to be called Philips Lighting. They're one of the biggest light bulb manufacturers in the world, but they have started moving more of their business into circular economy revenue, and one of it is to print the luminaires, which is the outer casing of the lighting fixtures that you have. And they're doing it for their commercial players. They're able to actually 3D print the entire luminaire using single material, which means that apart from rotating those lighting fixtures among their commercial clients, they can also bring it back, melt it down, put it back into a 3D printer, and print out new designs that can fit exactly into the walls, sort of holes and things like that. So very interesting revenue piece that's already been successfully implemented. It's been growing very quickly for Signify, this source of revenue. So 3D printing is definitely a technology that has that potential to disrupt, but how it would actually enter the rest of the E&E sector, I think that remains to be explored. Now, when it comes to these, of course, it again touches on the intellectual property rights. I think it's quite famous that there are some brands that do not allow any persons to actually take apart their electricals and electronic items. There's various patents along there. So the people involved in intellectual property rights, be it lawyers or people filing for those patents or those people enforcing those rights, there is definitely a component of players that's involved there that need to be considered. Apart from that, there's also the issue about data security, because when you're doing after sales care, it means that the first batch of users would have actually put in some degree of information into those assets. So the players involved in data security also therefore become really important, because they would be needed to sort of neutralize all that information, make sure that information doesn't get leaked into the wrong hands, and those consumer privacy related information also is protected as well. Okay, so that's the players from that perspective. Now, once we actually finish on the after sales care part of it, there is that potential, of course, to remanufacture. And again, you would need the digital product passports to document that transfer of that user into a remanufacturing realm, having a quality assurance players as well as the life cycle assessment people and the product carbon footprint people to really assess, what is the impact of this remanufactured item. But essentially, what happens is that when it's remanufactured, it gets passed on to a second or even third batch of users. And sometimes when these users complete their usage, maybe that product can no longer be remanufactured up to 90% or good as new guarantee. There is that possibility of those items then being moved into the sharing economy to users that perhaps don't need such high level performance of those electronics and electrical devices. So perhaps now, let's say the laptops only function to 70% performance. It may not be suitable for a corporate sector or for in their factories or things, but it may be suitable for schools that need a computer lab, etc. So that can actually go into a sharing economy. And it's the same like those who are doing maintenance in the after sales service, it could actually be to a sharing economy. When we're talking about sharing economy, there's actually two types of ownership that we need to consider and the different people that are involved in that. So the first one is in the sharing economy, it could be a transfer of ownership, right? So these are like those people who do resale of secondhand products after refurbishment or after remanufacturing. Whereas there's another type of ownership, which is called the shared ownership, whereby it's the sharing platform that actually retains the asset of and then leases it out to users, multiple users at the same time, right? So in order for that type of shared ownership, and you can see some examples of that from the library of things or the tool library, or there's also like another platform like Rent It For Me. These people are actually shared economy sort of platforms. But in order for that to function well, you would need other players to actually come in, including those that are involved with insurance for shared items. Because when you have different owners, you want to have some degree of insurance that would be able to recover the value of the product if, for example, it got lost, stolen, broken, etc. So if the insurance part of it can't really be settled properly, then it's a lot of business risk for a sharing platform to actually be leasing out electronics and electrical items that may be stolen or broken or damaged or whatever. Also, there would be a certain players in the quality and assurance, especially in testing and certification, that would need to come into play because every time the item comes back from being sort of borrowed from somebody, you would need to make sure that that electrical and electronic item is still safe to use. It's not going to like, I don't know, suddenly cause a fire or something, and that is actually still functional and performing well. So with that, you can sort of see that even in the sharing economy, it's actually more complex than just simply selling secondhand. There are a lot more players that get involved in that batch sort of like ecosystem part as well. And there you would actually see like you have like first batch users. So it could be new items that these sharing economy platforms put on, but it also could be second or third or fourth, fifth, sixth batch users actually utilizing those products. Now, of course, there's that option for then it to go back into remanufacturing. But from what we see in the market today, this is not happening. It's actually going straight towards recovery and recycling. And when we're talking about recovery, it's still like sort of with the major components and parts taken out as safely as possible. And then recycling, we're talking more about, crushing and just getting out the raw materials part of it, just for the purpose of differentiating these roles. That's why we do that. Now, if you look into that perspective, when we talk about just e-waste, it's actually very narrow, just looking over here, when actually there's so many other players that's involved early on in order for it to truly become a more circular economy, right? At every stage, be it from the product design or in the manufacturing decisions or in distribution decisions or the after sales care services or even product as a service and giving maintenance, repair, remanufacturing, or even refurbishment into the sharing economy. economy. These are all part of the circular economy of electricals and electronic items. And therefore, it is not sufficient to only look at e-waste as like an endpoint thing, because if you invest very heavily on just the recycling and the recovery part of it without the investment in the upstream components of it, then essentially what you're condemning these players to be is that if the circular economy were to happen for real, they would not have any more business, which gives you a conflict of interest, because in order for these recycling companies to continue to exist, they would need e-waste to continue existing. So a zero waste policy applied to electronics and electrical items would actually kill off their business in the medium long term. Right? So therefore, when we talk about planning for a circular economy, you cannot be planning for a circular economy for e-waste. You actually have to be looking at the circular economy for electricals and electronic items. And these recycling players should really be, getting further involved in the upstream. If they are really good at recovery, just recovering all these parts, components, not just the input materials, is actually a really essential part of it. And it's also necessary for those with high technical skills. So you're talking about developing human capital, not just to go into the low level type of recycling, but actually highly skilled, people going into the resource recovery components. And you really want to help those recycling companies eventually move up the chain in order to develop more value for the economy, rather than just simple recycling. Now, on that note, I think it's worthwhile to mention that there are other trends or factors that's influencing that ecosystem. One of it is the data platforms for ESG, mandatory sustainability reporting, that would come into play, because these tracking and tracing of the product footprint is something that is mandatory in the reporting itself, right? So this pressure on public listed companies to know what their suppliers are actually doing is actually a very useful force to help people actually understand that you cannot not talk about the life cycle in its entirety. It's not just cradle to the gate, which is ending at the manufacturing. It's not really cradle to the grave, which means it just ends up in the landfill or recycling. But you actually need to be considering the entire life cycle from cradle to cradle. And on that note, investors and standard bodies also play a role in this, because obviously they would need some degree of assurance that they're able to get back their money that they invested. Standard bodies helped in making that possible, because they sort of set out what is the most basic information that's necessary for helping investors make those decisions. And therefore, companies, suppliers, providers, they would need to also have that type of data ready so that they could be, even attract investment into their businesses. Of course, that said, this ecosystem cannot function without something called very basic data needed for business decisions. In order for business players to actually enter the ecosystem and, let's say, fill in these various gaps, be it in after sales care or the repair or the transfer of ownership or shared ownership, etc., there needs to be information about how many sort of electricals and electronic items there are actually in the market, how accessible they are, what volumes are they, and when are they going to be retired or expected to be retired. And you can get a guesstimation from that if you know when they actually entered the market. Same thing also in terms of the input materials. If the market authorities have allowed certain electrical items or electronic items to have certain types of materials, then you need to know what is that volume of materials within those items and those assets, so you can make a projection on whether or not it would be a viable business to be doing that resource recovery in the first place. So without that regulatory support or the policy support to have that information ready, it's actually really unfair to just ask businesses to somehow enter the market without that calculated risk of whether the business will be successful. Now, from the association standpoint, sustainability needs to be profitable in order to be sustainable. If these players who are filling in all these upstream gaps that would prevent e-waste from even becoming a problem in the first place, if they are actually to service that continuously, they need to have enough profits to be able to survive and to be able to grow their impact across different boundaries. They would also need profits.